So we've been looking at these PV curves, and you remember we had this curve with a shape, we had pressure on the y-axis, we had volume in the piston or above the piston in the combustion chamber on the x-axis, and we talked about how this was the compression stroke, where we're moving up the curve, we're compressing the gases. We have the ignition taking place up here, and then this is my power stroke, where the pressure comes back down and the volume goes up bigger. And we said a couple things. First of all, this is a theoretical curve, so it's got nice square corners on it. Nothing works like that. So we want to look at that in a little bit and say, okay, what does this really look like in there? But the other thing that we've ignored is the intake and the exhaust functions, the exhaust strokes. So we've got compression and power, and somewhere in a four-stroke engine we have to have the intake and the exhaust. And we often ignore those two because really what happens is they fall along this x-axis. So if you think about the fact that, all right, assuming I start here, I got gas in here, I compress the gas, whether it's the fuel-air mixture or gas in my compression ignition engine. I ignite the fuel, the power stroke comes down, so here's the power stroke, open the exhaust valve, it lets the pressure out, but as the piston comes back up, think about movement. So this was one movement of the piston where I went from bottom dead center here at my high volume, up to top dead center back here and back down. So that was two strokes. So on the third stroke, the exhaust stroke, I'm going to be moving back up. The piston is going to be moving back up the top dead center, and it's going to be pushing that exhaust out. So how much pressure is going to be in there? Well, not much. And when we think about theoretically, we usually assume that it's about zero or very close to zero. So what that really means is that curve is going to fall right along the x-axis. So that's going to look like a straight line right along here that's going to go clear down here to my top dead center point. And that's going to be an arrow right there. So that's my exhaust stroke. So my exhaust stroke goes that way. So that's pushing the gas out. Now what happens when I pull back in, so my piston moves back down this way, it's going to be pulling in some gas. Now is there going to be a vacuum on there? Yeah, and we'll look at that in just a second, but theoretically, relative to these pressures, it's not very much of a pressure difference. So that curve actually comes right back along there. So what I'll do is change the color just to show that the intake stroke then comes back along. And they should be both right on the x-axis, and I have a little separation there so you can actually see them. So the blue line is my exhaust, and the red line is my intake stroke going back and forth. Now, again, we talked about power. Remember that the power, we could look at this curve and see how much power our engine is producing or get an idea of it, because that's the area inside these curves. So if these two lines are sitting right on top of each other, there's really no power gained or lost there. That's just moving gas in, moving gas out. Now we know in reality that's not the case. There is going to be something going on. So what do those shapes actually look like? So let's break this down and just give us an idea, okay, in reality what's going to happen. So I'm going to do the compression and the power strokes over here on the left, and then we'll talk about the exhaust and the intake strokes over here on the right, even though they should be on the same graph. But I'll split them apart so that it doesn't get too messy in the graphs as we look at them. So what's going to happen? Well, basically, nothing's going to be square corners, right? Everything is going to be rounded. There's going to be some momentum, the air is mixing, and a lot of different things that are going on in there. So what won't change is the volumes. So eventually I'm going to get to this volume up here. So the line is going to have to be along these vertical lines, the bottom dead center and top dead center somewhere. That's still going to be my limits, but what are my pressures going to do in there otherwise? And it turns out what happens, and I'll go back to a blue line on here. So it turns out what happens is that along this compression curve, it stays pretty close the same of what that theoretical line is. So I'm compressing molecules of gas, that stays right along there. That follows, reality of what's happening. So the molecules are getting tighter, my pressure goes up. I've got equations to describe that, so I know pretty well what's going on. And it follows that pretty close. Now when ignition happens up here, that's when things change a lot. And again, We usually start our ignition a little bit early. Remember, we have that spark happening a little bit before top dead center, or the same way with the fuel injection and a compression ignition engine. We'll do that a little bit early. So what's going to happen is you're going to see that pressure start to jump a little bit early. So it's going to be more rounded. So it's going to deviate from that line. It's going to hit this curve. And then that pressure is going to be a lot more rounded. So you're just going to get a rounded kind of thing that looks more like that when it comes down here. And then when I open the exhaust valves down on this end, remember I opened that exhaust valve a little bit early, so I'm going to see that pressure start to drop. It's going to round off, hit this corner back here, and then start back up. So same basic shape, same idea, but now this is kind of reality. And again, that's what engineers look really hard at, is all right, what's really going on in there? How can I change that? How can I make those pressures bigger and redesign engines, redesign components, all that kind of stuff, different fuels. So those are some of the questions that we ask there, but that's what it looks like, okay? Now, what might be of a little bit more importance to us is what really happens with that the exhaust and intake stroke. And remember the exhaust stroke, we said, hey, that's right along the x-axis here, so we're pushing that exhaust out, and it shouldn't take much pressure to do it. Well, yeah, it is going to take some pressure to do it, because I have to push that exhaust. It's got to go out through that exhaust valve, so there's going to be some restrictions there and a little bit of pressure drop. And then it has to go out through the pipes, and if I've got mufflers and catalytic converters and whatever else on the exhaust, I have to push that gas through that exhaust to get it out through the engine. So, oh man, yeah, there's going to be some resistance pressure here. So instead of just going straight along that horizontal line, what I'm actually going to get is a curve that loops up like this. So I'm going to see that, and I'll kind of exaggerate this a little bit and make it kind of high, and it's going to look something like that. It's going to loop up around like that. And then my intake stroke, when I get up the top and I start to come backwards, I have to pull that gas in. So there's a vacuum, there's some sucking, so I've got to draw that gas into the engine. It's got to come through a carburetor, it's got to come through air filters, it's got to come through the intake valves. All that's going to be some resistance, so there's going to be some negative pressure. So as I do the intake, as I come back to the right on this graph, I'm going to see a vacuum. I'm going to see negative pressures. And so this curve is going to go down the other way. So that's my exhaust, and this curve is going to loop down around this way. So I'm going to see that kind of a thing, all right? So it's going to deviate that. A little bit of pressure is going to be some higher pressures in there. As I push that stuff out, there's going to be some negative pressures as I pull some of that gas in. So that's really what it's looking like. So why do I care? Oh, man, let's think about energy loss. First of all, let's dig into this one. Remember on here, I just mentioned this, that the energy that we're getting from this fuel is the area inside that curve. So I got a loop here, and the area inside of the curve is the energy that's doing work. Man, that's what I'm getting out of that fuel. That's the energy, that's the pressure that's pushing down in the piston, that's making the crankshaft turn, all that kind of stuff. I've got a loop over here too. Oh man, what's happening? On this loop, I'm going to have some energy loss, right? So it takes energy to push that gas out. It takes energy to pull the clean stuff in. So there is going to be some energy. This is a loss. So that's energy that I have to put into that piston somehow just to keep the system working. Now, it's a lot smaller than the energy I get out of the fuel to do useful work. And so this energy really is technically coming from the flywheel on your engine. You got that big heavy flywheel on there. And as that piston pushes down, it gets that flywheel turning. It's got momentum, so when I have to get that compression stroke going up there, it can do the compression, but it can also help me with the exhaust and the intake. So it has that momentum, wants to keep rolling and so forth. So there's some energy loss right there. But we also have some energy loss in this curve because I just mentioned it. I have to push that piston up, and I have to compress those gases. So that compression, to get those pressures up to where I want to ignite that fuel, that takes energy. Now, what does that look like on this graph? That's anything underneath this lower curve. So if I drew a line down here, crosshatch this area, this is energy lost. So that's energy that is not going out for useful work. I have to have that to compress the gas to make the engine work. So that energy has to come from the fuel. So part of the fuel energy can't go out to the crankshaft to do useful work. It's got to go to the crankshaft and be able to push that piston back up and compress that fuel. So there's a little bit of this energy that has to go back into the system to keep the system working, okay? So energy loss, this is the one main thing, is the compression stroke. And then the other main thing where I've got energy loss is this intake and exhaust. So the exhaust stroke pushing out and the intake stroke pulling back in, these two things there. So those are my energy loss. And here's where we start to think about, wow, okay, so if I think about the energy that was in that fuel that went into the engine, I can't get all of that energy from the fuel going out and doing useful work on my crankshaft. Some of that energy from that fuel has to go into just keeping the dumb thing running, just keeping the system working, being able to compress the gas, being able to get the gas out, being able to pull new gases in. That's all takes energy. So that's going to be kind of a parasitic thing from the fuel that goes into the engine. So those are energy losses. So that's kind of a more general picture about, okay, why do we care about these PV curves? Again, you know, they show us how much energy we have. We can start thinking about variations and modifications and how we move that curve around, how we change it. But it also gives us a visual picture of where our energy losses are. So the fact that, hey, that system has some inefficiencies in it, and there's not a whole lot we can do about it. We got to compress the gas before we light it. That's just the way it has to work. Okay. So that's PV curves and why they're important to us.